Welcome back. As I mentioned in the last video, this was getting a little bit long, so we cut it into two pieces. Today, we're going to take a look at the breadboard and just finish populating it and get everything working. In this section, we're actually going to start using code, so make sure you go ahead and get the Arduino IDE installed. As well, if you like these videos and you want to see us keep making them, please comment, like, or subscribe. And without any further ado, here is the rest of the breadboard video. Alright, so the first thing you need to do is open your Arduino IDE. You're going to need to make sure that you're connected to your Arduino. It should tell you in the bottom what you're connected to. If it doesn't, go to Tools, Board, pick Arduino Uno, go to Tools, Port, and try the different COM ports till you find the right one. You can also go through Tools, Get Board Info to try to check and make sure it's working on the board, or just hit Upload. And this will tell you right away if there's a problem or if it's working. Now, if it seems to be working and stops working at some point, just unplug the Arduino, wait a moment, and plug it back in, and you should be fine. One tiny little detail to add, if you look here really closely in the bottom of the breadboard, it says, please subscribe to Lloyd Summers on YouTube. That's odd. Okay, in my case it says done uploading. I also have a... Nope, that's not connecting. Let me just fix that. There we go. At the very bottom, you'll see that I have a little console logger. Control-Shift-M will open the console so that you can get some debug messages back just to make sure things are working. So the very first thing we're going to do, now that we've been able to connect and open our console log, is just do a serial dot, is it connect? It is begin 9600, and then serial print hello. Actually, let's have some more fun. EMF detector. So let's change print to a print line. And go upload. And if it works, we should see in our console EMF detector 1.0. And you can see that at the bottom of the screen. So that's good. That means that that part is now working. I'm going to go ahead and leave that piece in there. What we're going to do is set up our pins now. So we have a couple of different pins. We have an antenna pin, which is A0. We have the trimpot pin, which is A1. We have our speaker pin, which is D0, or sorry, D3 or 3. You'll notice that there's A1 and A0. Those, how it calculates those is interesting. So if you look up your numbers 0 to 13 on the Uno, A0 is actually 14. And if you were to console write A0, it would actually say 14 and 15 and so on. So whatever your last digital pin is, plus 1 is what the analog pins start at. But you can also just type A0. That's perfectly fine. We're going to also have how many LEDs we want. And the first starting pin is 4. And then the number of LED pins is 10. Because I have 10 LEDs, so I want 10, and there's 4. And the reason I'm putting these here is so we can use them in math later, just to make life a little bit easier. So now we've got those checked. We can go ahead and hit verify, just so it can compile and let us know if we made a mistake. So far, so good. Now I need to set up my pins, because pins can be input or output. I like to be explicit and tell it always what my pins are being used for. So technically the A0 and A1 are already marked as input, but why not be specific? Okay. Now our speaker pin is actually output. Now, I said a couple of times it's really important to have these LED lights in sequence, and I'm going to show you why. I don't want to sit here and type 10 different ints for each one of the pin numbers. You could, but that'll take up a lot of code. I'd rather have them in order so that I can just use a for loop. So we're going to say for each pin starting at LED pin start, where the pin number is smaller than LED pin start plus LED pins, and we're going to go up 1 each time. So you don't really necessarily need to understand what that's doing. Just know that it is going through and counting all the pins starting at 4 all the way up to 4 plus 10. So as soon as it gets to 14, it'll stop. So it doesn't process number 14. So it'll start at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and it'll stop. And that's what the number pin is going to become. So if I was to say, do a serial.print pin, push that to our Arduino, LED pin start. Push that to our Arduino. You'll see it says EMF detector. There you go. I have that backwards. So what it was doing is canceling right away because the pin number was, didn't meet the requirement of being smaller to keep it iterating. There you go. So now you can see this. That doesn't quite make sense. So let's go ahead and do serial print. But yeah, as long as this is true, it will add this to the end. And because I inverted this, it was no longer true. There you go. So you can see we're working through pins 4 to 13, which is pretty cool. So now that we can do it that way, we don't have to do this each by hand. We can just do pin mode pin output. And now we can do serial print line pin. And let's go ahead and be a little more descriptive. There we go. Go ahead and upload that. And you can keep working while it's uploading. So there you go. It's kind of hard to see it on there, but it's saying basically config 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me show it to you. So you can see it's got a much bigger range of numbers, which is pretty cool. Okay. And now let's go ahead and configure our loop. So we're setting everything up properly. Now we got to do some fancy stuff to figure out what's going on. So first, keep in mind we have that little trim pot, and he's got an offset reading. So let's go ahead and get his information. Is it called trim pin? Yeah. We're also going to go ahead and get the antenna reading, which is analog read antenna pin. So this will be between 0 to 1, no 2, 3. And this will be between 0 and 1, 0 to 1, 2, 0, 2, 3. What I want to do is if I turn this up, I want to take that value away from this. So let's go ahead and just do that here. So what happens is, as we turn up this one becomes less sensitive. Its bottom drops and drops and drops, technically raises up, so that it starts to trim out lower level values. So what do we want to do? Well, we only want the first 10% of the antenna reading, because it's never going to get to 1023, but it will go from about 1 to 100. So let's go ahead and get a result. And I want it to only be I want to basically do a max value between 1 and 100, which is you can do using constrain. So we're going to constrain antenna reading between 1 and 100. So we're trimming off anything bigger than 100, and we're going to raise it all the way up to 1 if it's less than that. So if you're wondering what's going to happen if this is subtracting and it's going too far into the negatives, this is what sets it to just a value of 1. Finally, we want to remap this for output. So these pins are between 0 and 1023. The speaker pin is between 0 and 255. So let's go ahead and get a result mapped. And the way this works is in constrain, this is the minimum value it can be and the maximum value it will be, and it will cut it off to make it fit within there. It's kind of like a clamp if you're used to C#. The map will say if you're between 1 and 100, multiply it and adjust it so that it's a ratio of 1 to 255 instead. So this just does basically a ratio. So if you know how to do ratios, you can just use the formula. You don't have to do it this way. But what will happen is, if this is a value of 1, this will get remapped to a value of 1. If this is a value of 100, this will get remapped to a value of 255. If this is a value of 50, this will get mapped to 120, whatever this is divided by 2, because it's equal to whatever this is divided by 2. And that's what the remapping does. Now, we could go ahead and start debugging, and if we do that now, we can actually get serial.print So this will now start printing the result and the result map beside each other, just to give you an idea of what's going on. And you can watch what I'm going to do with the this whole thing at the same time, okay? So let's go ahead and upload it. Result is what's coming in off of the antenna minus our trim pot. So you can see right away that the values, go. You know what? Let's go ahead and disable this for now. There we go. That way you can see my debug a little bit better. So what it's saying right now is that result that it's getting from the antenna is 1 or pretty much off, and the result mapped is 1 or pretty much off. Now if I reach over and start touching this, it's not changing, but if I change my adjustment, will that fix it? There you go. So now you can see when it comes into contact with me, it's starting to get other numbers, which is kind of cool. Let's go ahead and turn off auto scroll, and you can see. So it was 1 1 1 1, then it detected EMF at 84 and remapped it to 213 for what it would be on the speaker side. The map you can result map you can probably omit if you want, but it's just there for the purpose of teaching. Now if I start increasing my sensitivity or decreasing my sensitivity, you can see that I'm getting much smaller numbers. So if I turn off auto scroll, you can see I'm only getting 60s and 90s. There is a 100, but it's more and less sensitive. So that's all we're doing there, is kind of changing the sensitivity. Okay. Now, we've set up our readings. Let's do a little bit of math to make our lives a little bit easier. So how much of a voltage, or sorry, how much of a step up do we need to go for each LED? Well, to do that, we can do I'll call it a spread, but we're going to take this map of 255 and we're going to divide it by the number of pins. And the reason I'm doing it this way is if I decide to add or remove LEDs later, all I have to do is change this one value and it will take care of the changes for me. So this will now give me 25.5, which will round up to 26. So the max pin set should be result map, so what we've picked up, divided by our spread. So what's going on here? Well, we're taking the number of possible values and dividing it by the number of pins, and then we're going to find out what that pin should be by taking this value again and dividing it by this amount. So let's go ahead and take a look at what that means. So if we take a look at our running list and hit stop, you'll see that there's 1 for so the first 2 numbers are what we're sensing. The third one is which LED it should be turned on to, and this is saying none because it's not detecting anything. But if I apply something to this and then disable this, now you can see it's starting to say we should be on LED 2, we should be on LED 7, we should be on LED 0. That's what we're going to be able to use to determine how strong of a EMF value we're getting. So back to the code. How do we do this? Well, first let's turn on our LEDs. And then we'll do the audio afterwards. So remember what I said about doing 4s? We're going to do this again. Pin is smaller than LED pin start plus LED pins. So again, we're going to go through. Basically all this is doing in a really fancy way is making it count from 4 all the way to 13. So we're going to do for each one, valid result mapped would be spread. So this how much one pin is worth times pin minus LED pin start. So that's going to take the value. Basically what it's doing is it's taking this, which is the value of one pin, and multiplying it by its pin number. So 1 would be 25, 2 would be 50, 3 would be 75, 4 would be 100, and so on and so forth. And it's using that to stage it across the sequence. Because what we'll do then is say if the result map we've detected is bigger than this pin's valid result map, then we want to turn the pin on, because we've sensed a value bigger than what our pin is sitting at. Otherwise, turn it off. And that's it. So if we hit update and watch our unit, you can see it has that. Now if I put some pressure on, so now that's kind of cool. We're able to actually pick up and sense the EMF. And where is something I can use for this? Now if I take this little guy, how do I do this in a way that looks attractive? Let's turn the trimpot up. Now you can see it's not doing anything. And I can slowly lower that down until it gets to a value I'm comfortable with. There you go. So now it's not as sensitive. You can see it's not jumping as much because I've turned this up a little bit. So now we've created a way that they can make it more or less sensitive when they're in the field, basically ruling out some of the earlier lower level values, which is cool. Last thing I want to do is put this speaker to work. Keep in mind, we can turn the speaker on and off using that switch. So make sure that your switch is set in the spot that's between your speaker bar and your middle bar. So if your switch is on the right and those two wires are on the right, it's going to connect to that one. If your switch is on the left, it'll connect to anything on those two, and because there's nothing on this side, it'll effectively just turn it off. So let's go ahead now and turn on audio. Now there's a catch. I don't want the audio to play all the time, and we know that what the LED pin number should be. You'll also notice that I've set it so that it starts at 0. This way this light is always on. I want that so the person using the device doesn't get worried that maybe the battery's died. So we're going to say if pin max pin set is bigger than 0, then we want to play a tone on the speaker pin that is, so we can play a tone on the pin because it's a PWM pin, and we're going to take the value we have coming in, which is a result map of 0 to 255, but this is the frequency. This can go into the tens of thousands. So I'm just going to take 255, the result map, and multiply it by something to make it a little more noticeable of a frequency. Otherwise, no tone speaker pin. So that'll turn the noise off. So if one of these LEDs has lit up, the speaker will make noise according to the value it's picked up. Otherwise, it'll just turn the speaker off. This could get annoying, which is why I put on the speaker a small resistor. You'll see what I mean. Done uploading. So right now it's making no noise because it's only at LED 0. And if I make it more sensitive, so there we go. That is our rough proof of concept. So now we're able to go take some time and convert this into something we can actually use on a breadboard. I think that's pretty cool. The other thing we can do later on is experiment with different antennas and try to find a better antenna. But there you go. We now have created a very complicated but interesting little EMF detector. And unlike the other ones in the field, ours is going to generate audio that we can turn on and off. It's going to have a nice LED display, and it's got a sensitivity switch. We're now creating a fairly high-end EMF detector for anything paranormal. And just like that, we've created a very interesting proof of concept for an EMF detector with low-cost parts. Hopefully you join us next video where I come back and show you how to take one of these Arduino Micros and we turn it into a more production-ready unit. Now, I know we're going to get some people in the comments going, but Lord, you missed this. If you have a different opinion or have had other experiences, please feel free to share it in the comments. If you've created other projects that are similar, I want to create a very interesting community in around the paranormal and Internet of Things. So make sure to comment, like, or subscribe, and share your feedback. The next video should be our last one for this particular EMF detector, so start thinking about what videos you'd like to see us do next.